Hi everyone, my name is Kotomi. Today I am going to present chapter 7, which is time-dependent graphs. And learning objective is to discover different types of graphs for time series analysis. You can hear me, right?
Yeah, we can hear you.
Okay. So first, time-dependent graph is a graph that the structure changes with time. And this graph is really useful to analyze time series data to see how data behaves over a period of time. And we can also observe if there is any seasonality or cyclic change in the data. For the first example plot, we are going to use economics dataset from ggplot2 package. It contains US monthly economic data collected from January 1967 through January 2015. So let's plot personal savings rate using simple line plot. So first we load library ggplot2 and ggplot function. We have economics dataset and we have date as X and personal savings rate as Y. Here we specify plot type as geom line, and we have labels, title and X and Y. And this is the plot we'll get. As you can see, it's a very basic simple plot. And in 1975, it looks like personal savings rate had the highest peak, and 2005, it looks like it had the lowest. So now let's modify the previous graph, and we are going to use ScaleXState function from Scales package. By using this function, we can reformat dates in any way that we want to display on x-axis. And we are also going to use theme minimal function. And this function can remove all the unnecessary background elements and reduces the axis lines. So by using this function, our graph will look more clean and uncluttered. Here is the code. First, again, we load library ggplot2 and scales, and we have ggplot function. Now we in the geom line function, we specify color and size. And we also add geom smooth to see the geom smooth to see the overall trend. And here we have ScaleXState function. As a main parameters, we have date breaks and levels. And in this example, we use date breaks as 5 year and levels date format as small letter B to small letter Y. And we have labels and theme minimal function. And this is the plot we'll get. Compared to the previous plot, we can see the trend of the data easily in this plot. And now you can see the time period is, previously it was 10 years, but since we specified as 5 year inside of the ScaleDate function, now we have time interval is 5 years. And also, like in labels, we specified date format as like this. And basically, small letter b indicates that abbreviated month, name of the month. So here we have Jan as January. And small letter y indicates that two numbers of year. So here 1970, we have 70 as 1970. And for the ScaleDate function, I made small notes. So if you need brief reminder for its usage, please take a look at this page. But as I mentioned, ScaleXState or ScaleYDate functions takes mainly like two parameters. And date breaks function is used to set the positions of the tick marks on the x-axis. And this function takes only one argument, which is the unit of time. So for example, we can use 1 year, 6 months, 1 week, 10 days, like something like this. And for date format, I mean, like levels equals to date format, this parameter, this also takes a single argument, which is a string that specifies the desired format of the date. So for example, if we use this data format, it will show this like basic format. It will appear like this. And basically, like I listed some like I guess most common way of like how to write format. And for example, like capital B, like this shows the full month name. So January, February, etc. And if it becomes small letter b, it's going to be abbreviated month name. So Jan or Feb. And small letter d will show the 2-digit day of the month. And capital A will show full weekday name. So Sunday, Monday, Tuesday, etc. And small letter a is going to be abbreviated weekday. So sun as Sunday, mon as Monday. And I have some links here, which I found like really helpful. So like, please like use these as a reference. And if you have any comments or questions, please feel free to ask me.
No questions. I was just putting in the chat. It's cool. Like you just put the lowercase to abbreviate it. Yeah.
Yeah, I think it's also like easier to kind of like remember, right? Like capital letter for the full and like, yeah, lowercase for the like abbreviated version. Yes. So now I'm moving on to the next slide. Next, we have a dumbbell chart. And dumbbell chart is used to display the change between two time points for several groups or observations. And in order to perform this graph, we can use GeomDumbbell function from ggalt package. And for this like type of graph, we need to use a wide format dataset. And let me briefly explain what wide format data is. So here we have like long format dataset and wide format dataset. Originally, like this dataset, like we are going to use Gapminder dataset, but like this original format is long data, a long format dataset, and it looks like this. Like in the country, like we can see like two of each country names. It's because like it has like 2 year points in the dataset, like 1952 and 2007. And each of them has like the values of life expectancy. If we convert this to wide format dataset, it will look like this. Now, like in the country column, we like each country has like, how to say, like one each, like Argentina, Bolivia, Brazil. And as a column, like we have year of 1952 and year of 2007. And the values are now life expectancies. Like, I hope I'm explaining enough.
Yeah.
Okay.
No, sounds good. Yeah.
And I also have this like I found this website, and this also explains well. So when you have the time, like please take a look. And as a dataset, we use Gapminder dataset. And this comes from Gapminder package, and it contains for each of 142 countries, it provides values for life expectancy, GDP per capita, and population for every 5 years from 1952 to 2007. So now let's plot the change in life expectancy from 1952 to 2007 in the Americas. First, we load libraries and we load data. And since this original data is long format, we are going to subset data. And since the original data is long format, like I named this as plot data underscore long. And we filter continent as Americas, and year is 1952 and 2007. And select the columns of country, year, and life expectancy. In order to convert this long format to wide format, we use spread function. And now we create dumbbell plot using ggplot function. We have y is country and x is 1952 and x end is 2007. And we specify the plot type, which is GeomDumbbell. And this is the plot we'll get. As you can see, this plot looks like a dumbbell. Okay. So now let's modify a previous graph to make it easier to read. What I want to do is sort the order by countries and change the color and size of lines and points, and use theme minimal to minimize the theme. So here we have ggplot function, and for the country, we are using like reorder function, and we sort the country name by the value of year 1952. value of life expectancy in year 1952. And inside of Geom dumbbell, we have we specify size and also color. And we have the minimal function and labels function. And this is the modified plot. Now it's, yeah.
I was just gonna say very cool. I've never made a dumbbell plot, but yeah, this is very cool.
Like for me, it's also my first time using this plot, but like compared to previous one, it's now easier to recognize the patterns here. Like, for example, like the high T, it started with the lowest like life expectancy values and like still has the lowest like in 2007. And as you can see, this line, like this gray line, indicates the change in the value of the life expectancy between starting point 1952, which is blue color, and ending point 2007, which is red color. So next we have slope graph. Slope graph is really useful when there are several groups and several time points. And we are going to use new GG slope graph function from CGP functions package. And this function takes parameters in order, and it has four parameters, and it's in order. The first is data frame and time variable, numeric variable, and grouping variable. And this time variable must be a factor. And this numeric variable is the values that you want to plot on the y-axis. And in the book, it says numeric variable. This one is numeric variable, but it also accepts type of integer as well. So now let's plot the life expectancy for 6 Central American countries in specified year. We load the library and we create data frame. The original data gap minder, and we use pipe and filter years, like specified for years, and country. These are the countries in like Central American countries. And we use mutate to create a new column year using factored like year from the original data, and life expectancy is the rounded value of the original like value of life expectancy. And finally, we create slope graph. So we have new GG slope graph function, and we have other parameters. We have data frame df, year for time variable, life expectancy for numeric variable, which we want it on y-axis, and we group with country. And we have labels. And this is the graph and plot. In the graph, like Costa Rica has the highest life expectancy across the range of years. And this graph, like personally, I really like this graph, and I think it's really easy to follow the changes in the values.
Yeah, it's very interesting. And also like compared to the dumbbell, you can kind of see where like they intersect. Like it looks like El Salvador and like I think Nicaragua, I'm guessing. Like
Yeah.
where you see at like the 71 where like they intersect and I guess
Mhm.
change positions. So that's really
Mhm.
cool. Yeah.
And like it's a really good point. And if you see like the color also changes. So here like Honduras and Nicaragua has like 66, like it's sharing. So it has like slightly like stronger like blue. But since it's separating, it fades. The color fades to like lighter blue, and it fades to like lighter blue green. But since Guatemala like is like intersecting here, now it becomes to like darker green. So this is like I find it really interesting. And now next I'm going to introduce area chart. Area chart is basically a line graph, but filled from the line to the x-axis. And for this chart, we are going to use GeomArea function. And it is similar to a line plot, but like as I said, like instead of connecting the data points with a line, it fills in the area under the line. So here's the code for basic area chart. We are again using economics dataset from the first example. And inside of GeomArea, like we specify color, like which color we want to fill and which color we want to how do you say, like use as a line. So yeah, this is like basically like the simple plot with like the area is like colored. So next, I'm going to show you how to create a stacked area chart. This chart can be used to show differences between groups over time. And when we have interest on like both group change over time and overall change over time, like this chart is really useful. And for this example, we are going to use US pop age dataset from G cookbook package. And it contains age distribution of population in the United States from 1900 to 2002. So let's plot a stacked area chart by using US pop age data. We wrote data and we use ggplot function. We have data and X is year, Y is thousands, and we want to fill by age group. And we specify the plot type as GeomArea, and we also add labels. And here's the plot. So now, like we can see that the top of the layers is the youngest age group, and bottom layer is the eldest age group. And also we can see that scientific notification on the left, on the y-axis. And yeah, like if you are like really familiar with numbers and like good with math, like you can easily say like this number is like 300 millions. But I think sometimes it's really hard to come up with like the numbers with scientific notation. So we can like easily like change this scale by using ggplot2. And first we have to do divide the 1,000, which is like variables, by 1,000, the number 1,000, and we report its unit as millions. So I am going to modify the previous chart by changing the scientific notation as well as using this facet reverse function. And this function allows us to reverse the levels of the specified variable. So here is the modified version of stacked area chart. Here's the code. And first we load data and we have ggplot functions. As you can see here, like in order to get rid of scientific notation, I divided the variable thousands by 1,000. And here, like we specified field as age group, but in this case, we are using facet reverse. So they are going to fill the graph in the like opposite order of from the previous one. And inside of geom area, we specified color as black. And we have labels, and we have scale field brewer, and I set the color palette as set 2, and we have the minimum. And here is the graph. Now we can see that the youngest age group came on very bottom of the layer, and the eldest age group is on the top of the layer. And like we successfully removed scientific notation from the y-axis. So also, like you can see that each layers, like each area is surrounded by black color, right? It's because I specified color here, like in geom area as black. So if we want to use different color, let's say red, we simply can change here black to red, and it will surround with red color. Each area will be surrounded by red color.
Okay, nice. I guess I didn't even realize from the last one that it didn't have that. That is very cool.
Yeah.
Yeah.
And also, yeah, like apparently the number of younger children, like from this graph, like you can see that haven't changed very much in the past 100 years. And yeah, I guess we have declining birth rate and aging population.
Yeah, I think Gapminder, I think that's like from Hans Rosling, and we had discussed that in one of the classes. I think it might have been the research class, where it's like the idea of like the population growth exploding, but it was kind of like, yeah, usually like births kind of like stay stable. So it's like how the population is, it's like that people are living longer. Yeah, you can kind of see it. Yeah, it's very cool.
Yeah, also like as a reminder, like for this type of like stacked area charts, like it's really useful when we have interest in like group change over the time and overall change over the time. And like if we place the most important groups at the bottom, like it will be easier to interpret in this type of plot.
Yeah, definitely. Because I feel like I can't remember seeing like for the less than 5 years, it's more distinct now than it was before. So
Yeah.
yeah, definitely cool.
But yeah, this is the end of the slide, and thank you for following with me till the end. And it was kind of long slides, but I hope it was helpful for you or it will be useful in the future.
Yes, this is great. Thank you so much, Kotomi. Did amazing. Yeah. Yeah. But yeah, thank you everyone for joining today. And thank you again, Kotomi, for presenting. As I mentioned in Slack, we won't be meeting next week. Ken, Kotomi, and I will be graduating on Saturday. So it'll be good for us to have a little break. Yeah, but we can meet again, I believe the following week would be the 21st. And I'll be going over chapter 8, statistical models. So thank you again for joining, and I'll see you guys in 2 weeks.
Thank you.
Thanks.
Okay,
Bye,
bye.
everyone.
Bye.
Bye.
Thank you.